So questions from the homework from lesson 8. Just find the voltage difference between points X and Y. So first thing I'm going to do is label downhill. That's downhill, downhill, downhill. Next, I'm going to look for total current. I don't see amps anywhere. Next, I'm going to look for anywhere where there's two things. There's not two things there or there or there. I'm going to well, these four resistors are all in series. The total voltage of all four of these is going to add to 50. But I can't figure out any one of them. I would need to know three before I could figure out the missing one. So I'm going to have to rewrite this as its simplest mathematical equivalent. Now, the nice thing is these are all in series. So our total is just going to be 10 plus 20 plus 15 plus 5. That's a 15, Mr. Dueck, not an 18. 10 plus 20 plus 15 plus 5. 15 and 5 is 20, plus 20 is 40. You know what? Our total is 50 ohms. Mathematically, this is the same as a 50-volt battery and a single 50 ohm resistor, which means this also has to be using up 50 volts. That means the current is 50 divided by 50. It's 1 amp. That's kind of nice. So I got 1 amp right here. More importantly, I have 1 amp here. That means this is 10 volts. I'm doing the 1 times table in my head. I have 1 amp here. That means this is 20 volts because V equals I times R. This is 15 volts, 1 amp. This is 1 amp and 5 volts. Now, it wants the voltage difference between X and Y. That's this voltage difference right here, 20 plus 15. The voltage between X and Y is 35 volts. That's how I would do number 2. Number 3. Number 3 is kind of a nice question. I kind of liked it. I filled in part of it already. Let me do my little copy thing. I should get 320 volts. Let's see. So it said that 2 amps flows through the 3 ohm resistor. I already wrote that in. So what that means is that this must be 6 volts, I times R. But not only that, this is 2 amps, so this must be 4 volts. Not only that, this is 2 amps, so this must be 6 volts, which means this whole branch from here to here is 6 plus 4 plus 6. It's 16 volts. From here to here is 16 volts. And whether I go the long way with 3 hills or do it in 1 hill, those have to be the same voltage because we split up right here and we met up right here. So this must be 16 volts. I'm going to erase that little highlighter. I know 2 things. I can figure out the current. I equals V over R. It's going to be 16 divided by 4. This is 4 amps going this way. Well, if I have 2 amps going this way, I forgot to label downhill. I should have labeled downhill right away. There's downhill. I did it right there. If I have 2 amps going this way and 4 amps going this way, I must have had 6 amps coming in. Oh, and I have 4 amps and 2 amps rejoin. This must be 6 amps, which means I know the voltage. This has got to be 120 volts. And I know the voltage down here. This is 20 volts, 24 volts. What that means is this branch here is 120 plus 16 plus 24 volts. 120 plus 16 is 136 plus 24. This whole branch here is 160 volts. From here to here is 160 volts. That means from here to here is also 160 volts. This has to be 160 volts because, again, we were able to split up right here and meet up right here. By the way, also this plus this plus this plus this plus this has to add to 160 because on all of those we kept skiing downhill and we split up at the same location and met up at the same location. Knock, knock. I know 2 things. I can tell you this must be 10 amps. 160 divided by 16. I did the math in my head. Oh, I have 10 amps flowing this way. I have 6 amps flowing this way, 10 amps flowing this way. It must have been 16 amps flowing in. I times R, this has to be 160 volts. And now I can ski any path. The voltage between X and Y, it's 160 plus 160, which is 320. Or, I wouldn't do this, but I could have skied this path. All of those resistors will also add to 320. Or, I could go this way. All of those resistors will also add to 320. I wouldn't do it that way. I would do the simplest path, 160 here plus 160 here. We lose 320 volts. What's the voltage difference between X and Y? It's 320 volts. 160 plus 160. That was a neat one. Find the net voltage for cells. You know what? These ones in the same direction, it's going to be 60 plus 30, 90 volts. Cells facing each other, you gain 60, but then you lose 30. So this has a net voltage of 30 volts. That's why the answers are 90 and 30. What happens to the voltage drop across the 5 ohm resistor below when the switch is closed? Does it increase or decrease? Explain your answer. Let's just look at both situations. I think we kind of did one similar to this as a thought puzzle, using principles of physics right to explain question actually in the notes. I'm going to do this by solving when this is open and this is when this is closed. Make it a bit bigger. So open, closed. When the switch is open, like this position, this isn't even part of the circuit. I have a total resistance of 20 plus 5, 25 ohms. I have a total current of 100 divided by 25, 4 amps. Anyways, the voltage drop across here then, voltage across the 5 ohm resistor ends up being 4 amps times 5 ohms, 20 volts. If the current gets bigger, the voltage will get bigger. If the current going through the 5 ohm resistor gets smaller, the voltage drop will get smaller. Let's resolve this. Now we have, when the switch is closed, 2 resistors in parallel. 1 over R parallel is 1 over 5 plus 1 over 10. R parallel is going to be, I think it's going to be a decimal. I think it's going to be 3.3, but don't quote me on that. I got to try this. 5 reciprocal plus 10 reciprocal equals reciprocal. Yeah, 3.33 ohms. So our total is going to be 20 plus 3.33 ohms. I total is going to be bigger. I total is going to be 100, sorry, is going to be smaller. I said bigger, is going to be smaller. I total is going to be 100 divided by, no, it's going to be bigger. I'm so sorry. Original was 25 ohms. Now it's a smaller resistance, 23.33. It's going to be, let's even go 3.33 plus the 20, and then we're going to go I total divided by answer button. I'm going to get 4.285. You know what? I'm going to get 4.3 amps. I'm just doing some rough math here. Now, what that means is this is now receiving 4.3 amps because power is I squared R, and R just got bigger. This one is going to be brighter. But this also means it's using more voltage because now the voltage going through here is going to be 4.3 times 20. Answer button times 20. It's going to be 85.7 volts. Which means if I ski this ski run here, Now it's going to be 100, take away 85.7 volts. It's going to be 100, take away 85.7 volts, 14.3 volts. So the voltage decreases. Let's write this neatly, Mr. You know what? Let's type this. V decreases in the 5 ohm resistor. And that's because when you add a resistor in parallel, total resistance gets smaller, total current gets bigger, and because this top resistor was using the total current, let me get rid of the highlighter, because this top resistor was using the total current, the resistance didn't change, but current went up, voltage went up, less voltage left over here. When you close the switch, this bulb, if this was a light bulb, would get brighter, this bulb would get dimmer. And in fact, I think I kind of just answered number 6, didn't I? It says the bulbs are identical. So let's see if we can do this one intuitively without actually solving. You could always solve, make each one of these resistors like 2 amps, 2 amps, 2 amps. But when I close the switch, adding a resistor in parallel, R total decreases. I total increases. V lost in A then increases. V left for B decreases. So what does that mean? It means A gets brighter because power equals I squared R. I got bigger. B gets dimmer because now it's splitting the current with bulb C. There's less current going through here. Power is I squared R, or V times I. And of course C turns itself on in the first place, turns on. Otherwise, no electricity was going to it before. So, brighter, dimmer, on. And again, you can try making up numbers and crunching the numbers. I would probably lean towards using power equals I squared R, because you'll probably find I quicker, and then you can just go I squared R, make up a nice resistor, 2 ohms if you want to, because they're all identical bulbs. Number 7, this one's got some teeth. Although it says it works out evenly, that's always a bonus. One thing I do know is that this right here is 12 volts, because this is a legit ski run. Which means I know this is also 2 amps. That's all I can fill in before, oh, I should label downhill. Downhill, downhill, that's downhill, that's downhill, that's downhill. We're going down that way, we're going up this way, downhill. That's the path of this circuit. This is all I can fill in before I have to rewrite this. This 4 and this 2, I don't see as a 4 and a 2. They're in series. I see it as a 6 ohm resistor in the top. So right now, if I do a quick resketch, I see 12 volts here. I do see a 6 ohm resistor right here, and I know this is pulling 2 amps. I see a 3 ohm resistor right here. I see a 6 ohm resistor right here. And I can combine those top 2 into that. Now I need to combine these 2. These 2 are going to combine by going 1 over 6, because those are in parallel. I can't do the 3. The 3 is in series. But 6 and 6 are in parallel. If I go 6 reciprocal plus 6 reciprocal. I think it works out to 3, doesn't it? Yeah. This top one, this whole top mess here is just a 3 ohm resistor. In fact, because I have digital ink, what I'm going to do is I'm going to say this is the same as that. That whole top chunk is a 3 ohm resistor. And now these two are in series with each other. When I have a 3 ohm and a 3 ohm in series with each other, that's the same as a single 6 ohm resistor. So this whole mess works out to that. Ooh, and now I have two 6 ohm resistors in parallel. You know what? That's going to be 1 over 6 plus 1 over 6. I just did that. Let's get rid of this 2 amps. I can tell you that this whole messy circuit is the same as, so I had a 6 ohm and I had a 6 ohm. If I go 1 over R parallel is 1 over 6 plus 1 over 6. That's 2 over 6. This is the same as a 3 ohm resistor. This whole mess can vanish. This is the same as a 3 ohm resistor. Now, why does that help me? Now I can tell you this is 12 volts. This has got to be 4 amps. That's the total current leaving the battery. I have 4 amps. Now 2 amps went this way, so that means I must have 2 amps here. It's split up, but it rejoined. I know I have 2 amps in this 3 ohm, and I know I have 6 volts. Now, why does that help me? Because I can now ski this ski run here. I gain 12. I don't know what I lose here, but I lost 6 volts here. You know what? I must have lost 6 volts right here. I have to have lost 6 volts so that this path adds to 12. I know two things. This is 1 amp. I just had 2 amps was coming in. 1 amp went that way. By the way, I'm done. The current through the 3 ohm resistor is that way. But just to fully solve this, this must be 1 amp, 1 amp, 1 amp, 4 volts, 2 volts. So I did have to rewrite this. Number 8 says find the equivalent resistance. Okay, it's not saying solve, it's just saying turn this into one big uber resistor. I can do that. I'm going to start with these two on the end that are in series right here. I can combine these. That's a 12 ohm resistor. So I'm going to say that this circuit is really a battery, an 8 ohm resistor there, but in parallel I have a 10 ohm, an 8 ohm, and a 12 ohm. And I know those are in parallel because they all start at the same height. Right there is where they all branch off, and they all end at the same height. Now I can go 1 over R parallel. That's going to be 1 over 10 plus 1 over 8 plus 1 over 12. If I combine those ones, oh, wrong button. It's going to be 10 reciprocal plus 8 reciprocal plus 12 reciprocal. Don't forget to take the reciprocal of this. And I get, okay, 3.2432. I'll go 3.243 ohms. Now, what I'm saying is this whole mess is that. So I can resketch this one more time. There's an 8 ohm resistor, and this whole mess is a 3.243 ohm resistor. That's my new circuit. These two are in series, so I can just go 8 plus that, or as I'm going to go, answer button, plus 8. And I get R total is 11.2 ohms. Find I total, R total, and then all voltages and currents. I can already tell you that this question is going to need to be rewritten. I don't see two things anywhere. We'll include the answers just in case I need to check them. Okay, here I can go 1 over R parallel, that's these ones, is 1 over 100 plus 1 over 150. I can combine those two. They're in parallel with each other. 100 reciprocal plus 150 reciprocal, and reciprocal, this might work out nice, 60 ohms. These two I can also combine. It's going to be 1 over R parallel is 1 over 100 plus 1 over 100. I think it's going to be 50, I'm pretty sure. 100 reciprocal plus 100 reciprocal equals reciprocal. Yes. So this circuit can be rewritten as 120 volt battery. The top row is still a 10 ohm resistor. The whole right side is a 60 ohm resistor. The whole bottom is a 50 ohm resistor. Now this is nice because these three are in series. I can tell you that our total is going to be 10 plus 60 plus 50. It's going to be 120, is that right, Mr. Dueck? Yes, it is. 120 ohms. Now I'm doing good. I total is going to be V total over R total. It's going to be 120 divided by 120. Hey, I can even do the math in my head. Maybe you can. It's going to be 1 amp. So they wanted me to find total resistance, check. They wanted me to find total current, check. What else did they want me to find? All voltages and currents. So, well, this is 1 amp. So it's going to be 10 volts. The bottom, this is like a 50 ohm resistor with 1 amp. So this section must be using 50 volts, where this is using 10 volts. If this is using 50 volts, that means that's 50 volts, that's 50 volts. That means this is half an amp, which makes sense. This is half an amp. It makes sense because both resistors are identical. I was kind of hoping the current would split 50-50. Over here, again, if I go to my mathematical model, this is taking 1 amp. This whole section must be using 60 volts. That means this resistor is 60 volts and this resistor is 60 volts. So if I go 60 divided by 100, I might even be able to do that in my head. 0.6, I believe. I got 0.6 amps going this way. And I should have 0.4 amps going this way. Let's double check if I go V over R. 60 divided by 150, 60 divided by 150, and there it is, 0.4 amps. It said find R total check, find I total check, all voltages and currents. Voltages and currents, voltages and currents, voltages and currents, voltages and currents. Yep, check. Now, this is totally fair game for your test. I wouldn't say find all voltages and currents. I would probably say find the power used in the 150 ohm resistor, and you got to solve most of the circuit to get there. What was that? Number 9. Ten, and then number 11. Almost done. I love solving circuits. I've told you already, I find these like little Sudoku brain teasers. I think I saw somewhere where there's 2 things. I might not need to rewrite this. Let's find out. I got 2 things right here. I'm starting here. Well, first of all, I'm starting by labeling downhill. Downhill, 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 downhill. I can find the resistance. I'm not that interested. First, I'm going to try and find total current. Oh, yeah. I got 2 amps right here. I got 4 amps right here. That means I must have had 6 amps coming in. That means this has got to be Oh, I can write it right here. 6 amps. Not only that, that means if that's 5 amps, this has got to be 1 amp. That's not too bad. I think I can also ski. If I ski this run, I gain 72, I lose 36, leaving 36. I lose 20 more, leaving 16. This branch has to have 16 volts, as does that branch. No matter which of those I go down, it's got to be 16 volts. This has got to be 16 volts. This has got to be 16 volts. Also, I could say if from here to here, this way is 20 volts, from here to here, this way is 20 volts, because in both of those situations, we started and ended at the same point on our circuit, always moving downwards. So that means this here is 20 volts. Now I can do all of the resistances. Resistance is V over I, 36 divided by 6. This is 6 ohms. 20 divided by 2, this is 10 ohms. 20 divided by 4, this is 5 ohms. 16 divided by 1, this is 16 ohms. 16 divided by 5. What's a good way to divide by 5? Divide by 10 and then double it. 3.2 ohms. Last one. Says find the unknown voltage drops, currents, and resistances. I see one place with 2 things. As you see 2 places with 2 things. I might not need to rewrite this whole thing. Let's see. Let's hope for the best. I can tell you the current right. Well, first of all, label downhill, Mr. Dueck. Good point. Downhill, 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 downhill. I is V over R, so I've got 12 amps going through here, 12 amps leaving the battery. This question's going to fall apart. I don't know how yet, but it's going to fall apart. Here I know 2 things. I got 80 volts, 10 ohms. This is 8 amps. Well, if I have 12 amps coming in and 8 amps went this way, this has got to be 4 amps. And not only that, if I start here and end here, and this voltage is 80 volts, this voltage has to be 80 volts because I started and ended in the same location. So this has got to be 80 volts, and now I can tell you the resistance. R is going to be V over I. R is going to be 32 ohms. That's wrong, not 32, Mr. Dueck. Sheesh, I don't know how I did that. 80 divided by 4, 20 ohms. Thought you said you could do math in your head. Shut up. Yeah, you're right. That was not good. Bottom one. Oh, I know the current. It's back to 12 amps because everything is rejoined and the total current's going through there. I can figure out the voltage if I ski this run. Gain 200, lose 48, lose 80. Whatever's left must be here. So it's going to be 200, take away 48, take away 80. It's going to be 200, take away 48, take away 80, and I get 72. And now I know 2 things. I can find 3 things. The voltage is going to be, I'm pretty sure, 6 ohms. Because 72 divided by 12 is 6. I didn't ask for power on any of these, but power is V times I, or power is I squared R, or power is V squared over R. I got lots of options if instead this question had said, and that's on the test, I wouldn't say find the unknown voltage drops, currents, and resistances. I would have solved this and I would have known, oh, this is the one I'm going to find last. I would probably say find the power lost in this particular light bulb, if it's a light bulb, or in this particular appliance. I think that's all the homework from this lesson. There you go. Hope you found that useful.